Stanley Black & Decker provides tools and services around the globe to help turn great ideas into reality and to help us shape the world we live in. We proudly support programming that inspires invention, innovation, and hard work. Together with Make48, we're providing men and women the tools and resources to build a better world. Stanley Black & Decker, for those who make the world.
Previously on Make48, the teams presented their products to the judges.
The whiz-bang projects a target into the toilet, and if you hit it, you get awesome arcade sounds.
And the top 3 products were announced.
First place, G-Code.
Stay tuned as their journey to the marketplace continues. Make48, everyone's got a big idea.
After 48 hours is up, after the competition's over, the products have been chosen.
We have the chop guide, the whiz bang, and the drain cover. All have to be redesigned for that next level of product innovation.
There's a difference between invention and product development. Now, this process takes longer. This process can take 6 months usually. An inventor creates that first prototype, which is usually pretty ugly, and then he finds a company to license to, and that's where product development begins.
Think of it as a building contractor on a house. We have to bring in all the different people and teams to help put the process together. And we've got to worry about manufacturing, merchandising, redesign, and then tweaking the product all over again. We have to then talk to strategists on marketing, and all that has to happen to make it work. The inventors themselves do a great job to get the invention from their head to a working prototype, and that's often the stage that they will stop and let a product developer take it to that final stage. So my job now is to bring in 3 different design firms and pair them all with a product, and we have to get these products to the next stage so we can then start to produce short-run or even long-run manufacturing.
The first stop for G-Code's Chop Guide is Trident Design in Columbus, Ohio.
So Christos, you got the plans from the winning team for the Chop Guide. Tell me the process. How did it go from winning product, rough prototype, CAD drawings to what we've seen today?
The winning team had some initial CAD that they had developed, which you provided to us. And we brought that into the software we use called SolidWorks. In this CAD, we're able to simulate how the product could potentially function. So for example, opening and closing, we can do a series of section views.
I was actually surprised how true to the original design they stayed. A lot of the functionality of it was similar to the original one. It was just a lot more precise, obviously.
When you're designing this product, you're designing this with manufacturing in mind.
Correct. When you're designing a product, you're designing it with the intention to manufacture it, right?
Right. It always fascinates me how much work and detail just goes into the design phase. Very much like building a house.
And you're not just building one of them either, you're building a bunch of them. So now you gotta design for the assembly workers as well. You gotta design it so that the person in the factory can put it together easily. In the end of the day, that product needs to be able to be assembled, and you're designing the product for the consumer, you're designing it for the people in the assembly line, you're designing it, for the tooling. There's a lot that is involved.
Make48 is all about tearing down barriers so that average people, regular folks, can access the things that professional inventors and invention companies have access to. One being professional design and engineering firms.
And you'll notice that each product has evolved into something more market ready.
The whiz-bang poses several engineering challenges. Tom and Rich get assistance from the team at Pivot International.
Ryan, Dara, we brought you guys the whiz-bang prototype. There's a lot of challenges we have to do to get this product right. There's a lot of sensors that have to go in there. The product itself is small.
I don't think everything that we need to get in there is going to fit. The battery itself is about the size of that package, and that concerns me. On top of that, we need to put in a circuit board with a microprocessor on there. We need a little speaker. It requires quite a few things to go inside of there, and I'm not sure it's all going to fit inside that tight little package.
But we started out with the small design. We were thinking small, discreet, something non-obtrusive that could fit in a way you maybe wouldn't notice it until it came to life.
As you can see with the toilet seat, there's not a lot of room down there. So we're going to have a difficult challenge to be able to get a sensor and a laser to fit in that small area. Instead of placing it on the base of the seat, we actually place it on the base of the lid. The problem being then is you have 2 things you have to monitor at that point. It's not just the tilt of the lid to activate it, you also have to know if the seat's up or down.
We weren't really sure if the seat would have to be lifted or not, and that was a really important part of the process for us.
So the idea we settled on was we're actually going to put in a very similar sensor to what you see in the front. It's another infrared sensor. It actually has an emitter and receiver pair that sit together. They're focused in such a way that the light comes out when there's an object that passes in front of it that causes it to bounce back and it sees there's an object there.
So it's looking at the seat this
Yes.
way.
The success of Marquee Design's drain cover relies heavily on the suction technology.
We had the idea for a drain cover that completely seals a drain but still allows water to come through. So it was really a lion's share of our time was spent on researching how could we either create something that worked or at least find a parallel technology that could work.
We've gone to Larry Guerra and he is going to redesign this product. Toomey and Sadie made an amazing product, but we still don't know if we can make the suction technology work, and that was a big part of our judging process. Got a whole table full of samples. You guys have been busy.
We have.
Well, here you go. That's from the competition. I remember that one.
It's a great concept. The idea is for a suction cup, and this design itself is too tall, and the design here just doesn't lend itself to be a suction cup. So we started from here, and then we worked into it to design a more realistic suction cup, something we thought would seal to the sink. So here you can see we have a thinner one. There really wasn't enough volume under there to give us a good suction. Then we got a little crazy and got a little large, and that was a little too big.
Right.
But these worked really well as far as proving it out. We could do it quickly, we could print a mold in a day, and then we could pour it.
William, the two materials we're going to use for the suction cup, we've got two completely different things. We have a hard plastic top, and then what material have you used around here?
So this is a urethane to use to cast.
And the importance of two different materials is we need flex and a softer rubberized plastic.
That's right.
To suck down and seal, but then we need a consistency of the hard top so that it always pressurized in one motion, correct?
Right, that's correct.
When we were judging and we were talking in deliberation, we knew that the suction of this product was going to be the key for it to work.
Correct.
Right, so you guys have done a great job just to make sure that this process even works. After this, we're going to make a real life looking version, and that'll give us an indication of how close you guys got. We're here today at R&D Prototype, and they're the people we use when we take that product from early invention stage right through to final proof of concept. So Chris, the material, I'm very familiar with 3D printing, desktop printing, but what type of material is this actually going to be made from?
We utilize UV cured resin, $2,000 for 10 kilograms.
So this is a liquid form resin?
Liquid form.
$2,000?
$2,000 for that.
So you don't want me to drop this in a hurry?
Right. This resin will be cured by a solid state laser. The material itself's cured as soon as the laser hits it. So as you can see in the machine, the laser reflects off a mirror, comes down, and draws the geometry on the top surface of the resin. As soon as you see the blue light hitting on the top surface, it's curing that resin and curing it to the layer below it. So what happens is that platform drops down, the blade sweeps, it recoats on top of the previously cured layer, and then it will cure again, just like it's doing now. It's drawing, curing, whatever geometry is on that layer. And we're building in 4/1000ths of an inch layer thicknesses.
So Chris, when this part is finished, what happens?
When the part's finished building, it will be on the top surface of the resin. And then we will raise the platform up, the excess resin will drain off.
And tell me, how long is this process going to take to make this one part?
Every inch of height of build, you're looking at about an hour to an hour and a half of build time. Okay. So your part, you're looking at maybe 3 hours build time on a part that's 3 inches tall.
Okay, this is it, huh?
This is it. What we did is, you saw this coming off the machine. It's basically straight off the machine. And this is the finished product. After it's been sanded and painted, we give it a light EDM finish, which would look like manufactured, a nice light texture on it.
Okay, so you've sanded this, we've painted it.
Painted it.
And now the gasket obviously is the key.
And the gasket was the key. The SLA machines, the material is not going to be an elastomer. It's not going to be flexible. We want to be able to achieve the smoothness so you get the suction.
Right.
And that's why we chose the SLA. But in order to get an elastomer part, a rubber part, we need to build a silicone mold, what we call soft tooling.
Let's have a look at the silicon base. This is fascinating to me. I've never seen this before.
It's basically a silicone mold. We can do it for hundreds of dollars versus tens of thousands of dollars to create an injection mold that will meet the specifications of the production part.
This is like a giant gasket, right?
Yes, that's what it is.
It's going to act as our seal. So show me how this all fits together, Chris, if you don't mind.
So we have the ring and your center cap.
So now we've got the final product from R&D, and we're going to test it, and we have to look for certain things. Are we going to test it with stainless steel? Are we going to test it on tile for like a shower or a bath? But this is it. We're going to try it out and see what results we get. So the suction of this product is going to be the most critical component to this, right? Because the team that got third place, they designed it all about the suction. So the aim of the game at the end of this is that this product sticks to the ground. So let's see if she goes.
Can't get it off.
Guys, I wanted to show you what we did. We've come through the whole process of redesign and having to go through the challenge of making a prototype for your great product that you got third place at the show.
Right.
This is the most important part with any prototype. It goes through many phases to get corrected.
Yes.
And as we know, the suction underneath of your product was going to be the secret sauce to make this product work in the real world, at the consumer's house, in the bathroom, the kitchen. So Larry Guerra, he was designing this product for us and with us, and he went through approximately 10 different variations just to try to activate the suction. Okay, and they did that at their own internal location using 3D printers and pouring their own silicons, etc. They believe they came up with the right measurements here, right, for the compression that's going to be needed to create a suction valve to stay in place.
I'm very pleased with the new design of the suction and the whole entire drain cover itself.
What I can tell you is that it needs water to activate.
Okay.
So guess what? Let's try it out and see what happens. See if all this work is going to pay off.
Oh boy, see. Wow.
Wow.
Look at that.
It's working.
Wow. It's not moving at all.
You're moving the table.
Yeah.
You're moving the glass.
That is awesome.
That is awesome.
Oh my god.
Isn't that crazy?
Yeah.
As you can see, the design right here is the tab.
Okay.
When it's pressurized, the tab points up,
Oh.
and all you have to do is grab that tab and see what happens. Pull it up.
Oh,
wow. That is
Isn't that
great.
neat?
Yes.
Oh my goodness.
Wow.
So pressurize
That's
that.
amazing. That's amazing work, guys.
Yeah.
It just feels incredible that the idea we had actually functions the way Tom showed us.
It is awesome to see that it actually does work and that it's actually viable.
So what's your reaction on that first prototype?
It looks amazing.
It's a huge difference, huge
So much more
change.
attractive than the initial one.
A couple of design flaws we saw from the first one is the height.
Yes.
Yes.
If that's in a shower and it's sitting up that high, you've got a hazard to trip.
Yes.
And last thing you want to do is have someone trip and fall. We also have put a little indentation in the top. And the reason for that is that in a shower place, a lot of showers, you don't have the room to bend down and activate the product.
Yeah.
We believe that by putting it here, you could use the heel of your foot to pressurize it and get the suction to activate.
Yeah.
I really like the idea. It's a one-step application versus holding it down. It's definitely a lot more user-friendly.
What we thought of in the competition, we had the right spirit of what we were trying to do, but we believe that the industrial design has really improved it.
After getting redesigned, Tom begins sourcing the many components for the chop guide.
The lumber for the chop guide, this is a piece of art. It deserves to be treated with respect. And we're going to go to a small town in America and use a small wood mill.
These are the maple boards we were going to use. Now these have already been sawed, kiln dried. After we get them out of the kiln, we straight edge them, plane them down on both sides so they glue up nice and tight. And then we'll laminate these together. And like I said, the grains run different ways. That way it makes it stouter and stronger.
Anytime you have wood that's in a larger format, you have to segment it, you have to plank it, and have to rotate the growth rings. Tree always wants to grow in a round circle, so if you cut a board, it will always curl and warp.
Guys, this wood's been dried.
Yes.
What type of drying process do you use?
We have a Nile kiln, and what we do is it heats it up to about 110 degrees and sucks the moisture out. That takes almost 2 months to dry 2-inch lumber. Yes.
Really?
Yep. So from the time you cut the tree down, we saw it up, we let it air dry for a couple months, then we stick it in the kiln for a couple months. It's about 6 months before the tree actually comes out of the timber and goes to this. Yes, it's a long process.
It's a long process.
Yep.
And whenever he's done with this, he'll put clamps on this, and he'll have to clamp it all together so it all adheres the way it's supposed to, and then let it dry for at least 48 hours.
So after this is all glued up, it sets for 48 hours, what are we going to do next?
We will take this piece of wood back down to the mill and go ahead and cut the 1/2-inch strips off of it, and then you'll see the laminated pieces.
Right.
So we'll be turning the wood up and cutting it the other direction. Then we can bring it back up here again, and we run it through the planer, the sander, get it smoothed up and ready to be engraved on.
This experience has been really good for me. I've learned a lot, and I think it's something, information I can definitely use if I want to start my own woodworking business one day. I like making a lot of crafts on the lathe, and I had no clue all the work that would be involved in that, besides just making the product for a few hours that now I know about. And it's a good process. It's a long process, but it's worth it.
We decided moving forward that to get this product to be mass produced, it's better to have these panels laser cut.
So we went to High Tech Laser, a laser cutting company here local.
The laser cutting we thought was a major benefit because we can be precisionally cutting the wood.
Also, we got a benefit. When we laser cut the boards, it gave it that burnt look on the edges, smoky look, which added more value in my opinion.
So now the next step would be to etch this?
Correct.
To etch the writing on this?
Correct.
Like we talked?
Set it in there like that. Turn the exhaust on.
Looks great, Daryl.
Well, it is done, and there you go.
What do you think, Tom?
That looks neat.
Steve, you're right. The etching is great. Wouldn't have happened without you guys.
Yeah, good job,
I
boy.
appreciate it.
Thanks, Bob.
Very
Thank
smooth.
you. You're awesome.
Tom, thanks.
With the outer housing redesigned, the team at Pivot start work on the infrared heat sensor for the whiz bang.
So we've got a problem now with this product, making it work with the IR sensor. The IR sensor has to detect a small change of temperature from the temperature of the water in the bowl to when that kid is peeing.
We walked into the engineering lab. It was just like being home. Here they have this 5-gallon bucket rigged up with an aquarium pump and an aquarium heater heating up the water to about 98 degrees. And the aquarium pump shoots this stream out into this 5-gallon bucket, and this thing's all Frankensteined up, you know, with wires running everywhere. It looks like this out of a mad scientist lab.
This is a proof of concept. This allows us to show off and make sure the sensor actually functions. So what Les has got here is, you can see he's got hot water or warm water being pumped through the system, and it's not being detected by the sensor right now. So when he moves it in front of the sensor, you hear it start playing the song.
It's exactly the way I would have done it in my shop. But it was working. It worked great. And that's the best feeling, is when you see it work. I love that.
We've shown that this is actually going to work, and that it will function for what we need it to do. That sensor, this is obviously a proto board. It's huge. The sensor itself is much smaller than that. The next step is we just have to get all that to fit into this. So this is our 3D printed kind of proof of concept unit. We have to basically make a custom board to take that sensor and put it in here.
So this is our circuit board assembly house. This is where we do all of the assembly for the circuit board that's going to go in the whiz bang. So over here we'll start with the solder paste station, move to the pick and place, and then the reflow oven. So let's take a look at some of the machines. This can take a full panel. I'll go to a machine like this, apply the solder, pull it across there, and then fill it in so you can get the whole panel done at once. This is basically a robot that picks components off of a reel and places them onto the board. It uses a camera to align the board to ensure that it's in the right orientation, and then finds markers on the board to place the components.
So the components come right off of this tape?
Yes, they're actually, they're placed onto there, and when the tape gets inserted, it peels the covering off, so the vacuum can pick it up and place it. Okay guys, this is the final product after all the parts have been placed on the boards.
So there's 12 boards right here?
Yes, actually there's 12 boards per panel. So you'll see that to make it simpler, we can program it once and you can do 12 boards at one time in this particular configuration.
And the whiz bang's taking what, 2 panels?
Yes, it'll be 2 separate individual boards, then they'll be broken apart and then final assembled. Then we will take the boards and put them through the oven over there. That will cause the solder to melt and flow onto the board, creating an electrical bond.
Right here in the heartland of the United States, we're doing this high-tech, fantastic, automated manufacturing. I love it. I love watching it. I love seeing it. It's like music to my ears to hear these machines go.
Boys, I'm not going to lie to you, this project has been fun. We've had a lot of good times working on this whiz-bang. We've come up with phase 2 of the invention. We think it's looking pretty good. So, Rich, what do you got?
Well, I have a new product, brand new prototype, ready to show you guys.
Cool.
So here it is. Here's your new one.
So the whiz-bang, I think, is looking great. It's certainly changed direction a little bit.
We had to change the mounting location of this because of the size, for one thing. This physically couldn't go down here. But
It looks really different. It's a lot bigger. I don't know that bigger is bad. I think it's fantastic. You know, I think it'll work really, really well.
It kind of took it from something that looked kind of gimmicky to a real product.
This does not have the sensor working in it yet, but we were out at Pivot, and they do have a prototype, larger one, with the sensor working. Great. So it's real cool. Yeah, they were shooting water at it. They heated up some water in a fish tank, cool. And they had this little hose, and they'd shoot it through. And when it went through the beam, it played the song.
Yeah,
it played like a little 8-bit music song. You know, It sounded pretty cool.
So it's looking good. I see we've got a switch. Idea was, all hands-free. Is that switch going to be there in the end and the final one?
Great point, yeah. No, that switch is just on here for right now. That's just for the prototype. It actually has a sensor that's going to look this way as well, and it will see this when it comes up. If the seat's not raised, it will not be on.
I think it looks fantastic. I agree with you that it'd be nice if it got a little bit smaller, just for the way it looks. But it makes a lot of sense to move it from the toilet seat. When we were designing it, one of the reasons we had it down there, it was to make sure that the seat was lifted.
Right.
And it sounds like we've solved that problem, which is excellent. I think the guys at Pivot have done a really, really good job.
There's just one more step to go in finalizing the new Chop Guide prototype.
So the process after the wood is the plastic board. We use Mid-Missouri tool and die.
This machine is 250 tons. And what does that 250 tons mean?
That is the clamping force, the pressure used to keep the mold closed during the injection molding process.
Right. And how long, when that clamps shut, how many seconds before a chop guide chopping board is going to fall out?
Currently with this part, we're running about a 35-second cycle. So every 35 seconds, we're producing a finished part.
And of course, with the chop guide, we've got 4 different colors.
Correct.
So we have to run all one color.
Correct.
And then
purge the machine out.
Okay.
Put in the second color. Run all those parts out. We'll have to do that 4 times.
So before it goes into the machine, what does the plastic look like?
This is an example of the high-density polyethylene in its raw form.
So when we add the color to this, what's the ratio of this clear plastic and the color?
You add it by weight, and it's 1% by weight is what the colorant that you add.
The companies have given us all the products we need to now assemble. And of course, when we assemble one product, it's not going to be easy because no one's assembled the Chop Guide for a mass production product. So Bob is going to be assembling. Let's see if we can get it all to match, and then hopefully after that we have a few more tweaks, and then we can show our team what we have.
I've been waiting for this moment. What do you guys think? Let's go. Here it is. Chop Guide version 2.
Yeah.
Yes. When they came to the product redesign on our product, when they revamped it, in a sense, they kept true to the form that we had, and it's what we wanted the purpose of it to be.
Nice. What do you guys think?
Looks great.
Really Big difference, huh?
Oh, yeah.
We had more time than just 48 hours.
Yeah.
The hinge looks amazing.
Yeah, the hinge
Yeah, so we did a walnut hinge for an accent and laser etched it to say Chop Guide.
Yes.
A little bit of branding there.
When I saw the new design they came up with the hinge that rotated almost 360 degrees, I was really excited about that.
Our first design, it was good, but there was some kinks. So seeing it be flushed out and sleek, it's been really nice to see that.
So what's the price, Tom?
Well, Bob, what we do know is the manufacturing into this product, it's quality. There's a lot of machines, there's a lot of human at the very end to make it what it is today.
A lot of craftsmanship.
A lot of craftsmanship. We're not cutting any corners, we have to do it right. As this stands today, it's going to look like it's going to be a $99 retail. So, guys, this is obviously phase 2, but we're going to keep moving on this and phase 3 and get it ready for retail, get it ready for the end consumer. What's your thoughts and feedback?
It's very impressive. I feel really great about the product. They stayed true to the design. I just wasn't expecting. I thought they were going to change it a lot, and it was cool to see that they stuck with a lot of our original ideas.
Yeah, I'm really excited how it functions, just like how it magnetizes so easily like that. Just like snaps right back in.
I envision the packaging when it's delivered to a home, you're opening it up, you're going to see it's like a piece of art. It's a great product, great craftsmanship. You're going to feel like you bought something really high quality.
On the next Make48, the new prototypes are shown to the mentors.
It's beautiful. That's my first impression, is that it's a statement piece.
And marketing strategies are created.
So we really, really want to know everything about the product.
Make48, everyone's got a big idea.
Stanley Black & Decker provides tools and services around the globe to help turn great ideas into reality and to help us shape the world we live in. We proudly support programming that inspires invention, innovation, and hard work. Together with Make48, we're providing men and women the tools and resources to build a better world. Stanley Black & Decker, for those who make the world.
To learn more about the invention process and to get to know the teams, visit Make48.com.